Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to discuss what is termed as the negative binomial distribution. The negative binomial distribution is a series of independent Bernoulli trials with constant probability P of success. So what the negative binomial distribution does is that it observes the number of trials until we achieve what? Kth success. Okay, so for instance, maybe the number of pregnancies required before the third boy child is being what? Born, right? The number of shoots that a person, the number of shots a person will shoot until the person hits maybe the fifth what? Success. Okay, so all these experiments are termed as what? The negative binomial random what? Variables. Okay, we are saying that the negative binomial distribution, right, one way or the other, they appear in two ways. Okay, the first way is what? The number of trials until kth success. Okay, the second is what? The number of trials before the kth, so the number of failures before the kth what? Success. So we been understanding the introduction of the negative binomial distribution, let's dive into how we understand the PMF for the negative binomial distribution. So here we have two definitions. The first definition says that in a series of independent Bernoulli trials with constant probability P of success, let the random variable x denote the number of trials until k successes occur. So here, if the random variable x denote the number of trials until k success occur, then the PMF would be what? X minus 1 divided by k minus 1 times p raised to the power k bracket open 1 minus p all raised to the power x minus what? K. Already we know that our x is what? The random variable. Our k will be what? The number of what? Success that occur. P will be what? The probability of what? Success. Okay, so that is what the description for that. The second definition says that in a series of independent Bernoulli trials with a constant probability P of success, let the random variable x denote the number of failures before the k success occur. Then k has the negative binomial distribution with parameter P and what? K. Okay, so once our k represents the number of failures before the kth what? Success, then our PMF will be what? X plus k minus 1 combination k minus 1 times p raised to the power k bracket open 1 minus p raised to the power x. So always you have to pay attention to the random variable, the definition for the random variable in the question. So if the definition is to be what? The number of trials, or if the definition to be the number of what? Failures, then you know the PMF to use in this what? Case. Okay, yes. So sometimes, as usual, they usually can ask us to calculate what the mean, variance, moment generating function and characteristics function of the negative binomial distribution. So how can we achieve that? We are doing it for one way. That's what? The number of trials until we achieve the kth what? Success. Okay, when we are done, we are going to do it for the number of trials, the number of failures until we achieve what? The kth success. Okay, so the expectation here would be what? K divided by what? P. That's expected of x to be k divided by p. And then the variance would what? K bracket open 1 minus p divided by p raised to the power what? Square. And then the moment generating function would be what? P times e raised to the power k, t bracket divided by 1 minus k times e raised to the power t all raised to the power k. And then the characteristics function, anywhere you see t in what? The moment generating function for the distribution, there just repeat I times t there, and then that will be what? Our characteristics function, as you can see here. Okay, so there is the mathematics behind the negative binomial distribution. In our next video, okay, we are going to solve more examples on the negative binomial distribution. Thank you. Have a lovely day. Bye.